convex lens is center is thicker. Concave lens is side is thicker. So this lens center thin, the side is thicker. So this is concave lens. Okay, this one center is thicker, side is thinner. Okay, center thicker, so convex. This one center thin, side thick, so this is concave. This one center thicker, so convex. This one center is thicker, convex. This one center thinner, side is thicker, so concave. Continue. Okay, so optical center is the point at the center of the lens. Light ray passing through optical center are not rectified. So this is the optical center. Light that pass through, don't care whether it go through like this or go through like this or go through like this. All the light that pass through the center will not be reflected. So this is the same for concave lens too. This is the principal. This is the optical center. And then principal axis is a straight line through optical center and the center of curvature of both surface of the lens. So this is the curvature. This is the center of curvature. So this is the principal axis, the line that passes through the optical center and the center of curvature. And then axis of lens, the straight line through the optical center and perpendicular to the principal axis. So this is the axis of the lens. Okay, this is axis of the lens, axis of the lens. Okay, object distance is distance between object and optical center of a lens. The symbol that we use is a small u. Image distance, small b. It's the distance between image and optical center of a lens. Focal length is the distance between focal point F and optical center of the lens. So for example, light pass through the lens and converge here, focus on this focal point. So the focal length will be the distance between the focal point and the axis of lens. While for concave lens, the light that pass through diverge. So it will look like the light come from this point. So this point will be the focal point of the concave lens, and the distance between the focal point and the axis of the lens or the optical center. So this will be the focal length. Okay, so focal point is a point located at principal axis of the lens where parallel light ray will converge to. Okay, light that pass through parallelly, it will converge and go to the focal point. Only light that parallel to principal axis, all the light that is parallel to principal axis, it will go to focal point. Okay, focal point of convex lens is real because refracted light converge at this point. So actual light or light actually converge here, really got light here. So the focal point is real. Okay, and the focal length is positive. Okay, focal point for concave lens, the point located at principal axis of lens where parallel light ray will appear to be diverging from. Okay, so this is the focal point for concave lens where it looks like the light diverges from this point. And the focal length is, focal point of concave lens is virtual because refracted light ray appear to diverge from this point. Okay, it only appears to diverge. That means not actually diverge from this point. It does not, the light only look like come from this point. The light doesn't actually come from this point. Okay, so because it is not real, that means it appears to come from here, but not actually come from this point. So the focal point for concave lens is virtual, and the focal length is negative. So convex lenses are known as converging lens because the light converge. Light that pass through converge. Concave lenses are known as diverging lens because the light that pass through diverge. Okay,